For steel, we have cross section. We transformed concrete. Steel to concrete. So area steel will be multiplied by N, which is modular ratio, to get the equivalent concrete. If you are looking for sigma steel, you have to add modular ratio, N, then M, Y over I. Some of you forget N. For concrete, it's okay without N. Why? Because this cross section is concrete. Okay, My over I. But you are talking about steel, and this cross section is concrete right now. So I have to go back to steel by using N. One more one more point. Inertia for a rectangular cross section, BH cube over 12. One student, one of you did it like this, BH square divide 12. That's wrong. The last thing, guys, there is a big difference between, I think Nancy did it wrong. We learned that we have stress strain curve between for concrete and looks like this. Do you remember what is the highest value here? You have to remember F prime C. This F prime C will be used to figure out two things. E of concrete, 75,000 square root of F prime C. FR, which is 7.5 square root F prime C. Sometimes in stage number 2, which is working, I can give you something called FC, which called allowable stress of concrete. Sometimes this value for 1,400, 1,350, sometimes it's 2,000. This one is not this one. FC is something here, like this value. I can call it F, capital FC. I cannot use this value to figure out Young's modulus or figure out the tensile strength. The only value is used here, something called F prime C. F prime C, not allowable stress. Allowable stress means I reduced this one by factor of safety to use this value. Okay, one of you, I think, one of you did it wrong, as I remember. Any question, guys? Thank you, Oliver. Any question from last time? Last time we covered only something new, how to figure out the value of phi based on the strain in steel reinforcement. Okay. We have case number 2. What you mean by case number 2? The cross section is given, B and D. And the applied moment is given. I did structural analysis from last semester, and I can figure out M ultimate, and I will let you know how to do this just today, just a few minutes later. So cross section is given, applied moment from structural analysis is given. How much steel reinforcement we need? We need to figure out the steel reinforcement. We will find a factor or value called M ultimate divide phi time B time D square. B is the width of the cross section. D is the depth of the steel reinforcement. Phi, we will assume it 0.9. M ultimate, be sure that your M ultimate in pound inch. in pound inch. Wow. All the time we convert from pound inch to something else. No. Right now, if you have something else, please go ahead and convert it to pound inch. For example, if your moment is pound foot, you need to multiply it by 12 to be pound inch. If your moment in kib foot, we prefer this unit for moment. Okay, go ahead and multiply it by 12,000 to be pound inch. 12 for foot, 1,000 for kib to be pound. Okay? Then go ahead and find this number. Once you find this number, I can find from a table the value of rho. I'm sorry, what is the meaning of rho? It's called reinforcement ratio. This rho equal area steel divide B time depth. So right now, I can figure out the value of rho from a table. And B and D are given from the cross section. So finally, I can figure out the value of area steel. It's very easy. Very easy. Where is the table? We have a table. We have a tables here. Which table? Table 8. Table A8 and the table A9 and the table A10 and the table A11 and A12 and A13. That's it. And A13. So let's do one example and see what's going on. We have this example, example number 2. We have a given cross section. B equal 14 inch, D equal 21 inch. Next week, I will let you know how can we figure out these dimensions. We have some limits we need to follow. If the applied ultimate moment, so M ultimate is given equal 100 kib foot. So first step, I believe we need to convert this value to be pound inch. So 100 will be multiplied by 1,000 for kib, another 12 for foot. Your final answer will be pound inch. So your final answer will be 100 times 12,000 will be 1,200,000 pound inch. Second step, we need to figure out this value, M ultimate divide phi B D square. If you go back, we need to figure out this value, M square divide phi D square. Phi equal 0.9. So M ultimate in pound inch is 1,200,000. Phi 0.9. B for this cross section is 14 inch. D for this cross section is 21 inch. So 21 square. Your final answer for this term, 1,200,000 divide 0.9 times 14 times 21 square. Don't forget square. equal to 115.9. So I need to go to a table to figure out the value of rho. You mentioned we have many tables. Let's start with the first one, A8. A8 only if your steel reinforcement has F yield 40,000 and F prime C 3,000. So I need to go back to my problem. Given steel yield stress 60,000. So F yield is given 60,000. F prime C, which called concrete strength, 3,000. So we need to look to a table with these parameters: 60,000 for steel, 3,000 for concrete. So not this one. This one is a continue for the previous one. Not this one, because here is the F yield 40,000. We are looking for 60,000. Not this one. This one is 50,000. Here you go. This one is 60,000. What is the value of F prime C? It's 3,000. Is it yours? Yes, 3,000. So we are in this table. So which table I will use based on what is the value of yielding stress, what type of steel you are using, and what is the strength of concrete you are using. Very important, two parameters. Okay. Remind me, what is the value of M ultimate divide phi BD square? It's 215.9. Okay. We have here this term. Can you figure out your value? One more time. What is the value? 215.9. 215.9. So which one? 215, 215, 215. I think you are here. We will not look for a smaller value, but you can get a higher value. If you didn't find the actual value 215, okay, go ahead and use the nearest higher value, which is 217.8. What is the value of rho? 0.0038. Guys, any questions so far? Any questions so far? Yes, Oliver, yes. Phi all the time, 0.9. Why? I will let you know soon. Okay? So it's very simple. Just very simple. I will go back to the original story. From a story, one part of the story, we are looking for our structural analysis calculations, so we can figure out the value of M. Then this moment will be divided by phi BD square. All the time we are using phi equal 0.9. So we can figure out this value. Please pay attention to which table you are using based on what is the value of F yield, what is the value of F prime C. Once you select the correct or the appropriate table, I can figure out this value and then rho from this table. Please go back 0.0038. I need to write it out, 0.0038. I need to go back to a previous table in A7. And steel grade 60, which is F yield equals 60,000. And F prime C equals 3,000. I need to figure out the minimum value of rho. Rho minimum. We need a steel reinforcement higher than the minimum amount. We have a minimum you have to put in the concrete beam. So your reinforcement must be minimum or higher. We cannot go below the minimum value. So one more time, how can I use this table? One more time. It's very easy. Very easy. It's only one table. It's only one table. From this side, I need to figure out the type of steel. Based on the F yield, 60,000. So you are in grade 60 with 60,000 PSI. From this one, I need to figure out the value of F prime C. F prime C is 3,000. So we have here 3,000. We have here different values. This row, this row, this row, this row, and row minimum. So I'm going to use this one. So row minimum for our case equal 0.0033. Your row from the table based on M ultimate divide phi BD square equal 0.0038. I think you are higher. You are good. I think you are good. Just check. What will happen if your row smaller than the minimum row? Okay, forget your value and use the minimum. If the row from a table is smaller than row minimum, please forget your value and use the minimum value. So right now we are good. Your row is good to be used. So I will go back to my example. Row equal 0.0038. Yes. Row equal area steel divide B times D. B in inch, D in inch, area steel in inch square. So row is dimensionless. You are right. Okay, so 0.0038 equal area steel divide B 14 the time D 21. The only unknown in this little equation is area steel. So I can figure out the value of area steel. Your value of area steel equal 14 times 21 times 0.0038. Your value will be 1.1172 inches square. We need to convert this one. For example, how many number of bars? Number 3 or number 4 or number 5. If I choose, if I choose number 3, how many bars? You know how? How many bars for number 3? So I need to open my table. Do you remember? First table. First one. Number 3 has area equal 0.11. 1 bar of number 3, the area of cross section equal 0.11. So how can I convert this total area steel to numbers of to bars of number 3? So I will divide this value, which is area steel, divide 0.11, you will have 11 bars of number 3. So area steel equal number of bar time area of 1 bar. Area of 1 bar, you can get it from a table based on the size of the bar. Area steel, we figured it out. So I can figure out the N. Be careful, your number equal 10.15. So I will go higher to be 11 bars. Okay, I found 11 bars is too much, 11 bars, too much. Let's try number 4. So I will go to my table. For number 4 bar, the area equal 0.2. So I will divide the area steel, which is 1.1172, divide 0.4. Is it 0.4 or 0.2? 0.2, I'm sorry. 0.2. We need 6 bars. Good. If you would like to go smaller number of bars, it's okay. We still maintain the required area steel, don't worry. But we are talking about construction. Do you prefer 11 bars or 6 bars or lower? You know? So based on the construction, speed, easy of construction, all of this stuff. Okay, let's try number 5. What is the area of number 5? 0.31. So I will divide 1.1172 divide 0.31. I will use 4 bars. I think, in my opinion, this one will be better. If you have a huge number of bars, you can expect some difficulties for compaction of concrete. You can expect segregation, you can expect nest of concrete, nesting. We can expect issues of pouring of concrete with this huge number of bars. So we prefer to maintain, to keep the required area steel with smaller number of bars, but not less than 2. The minimum number is 2. You cannot go less than 2. Any question for this point? So right now we learned it. I'm trying to complete my whole story, but step by step. So right now, M ultimate is given. So I can figure out this term. I can go to a table to figure out the value of rho. So I can figure out area steel. Based on the selected bar, I can figure out the number of bars. Until this moment, minimum reinforcement is just to, it's related to ductility, cracking, but in a different term, which called ductility. Ductility means you have to keep cracking within the limit. You have to keep deflection within the limit. You have to keep the behavior, the actual behavior of the beam within the limit. It's not accepted to see a reinforced concrete beam deflected too much, or you are watching a beam with cracks which is visible to you. So we maintain minimum reinforcement to delete all of this stuff after construction. Okay, so your value of rho must be higher than the minimum value to keep the beam safe. It will be safe, but to keep the beam safe against surfaceability limit state, which is cracking. We will talk about this later. Don't worry, Roberto. Okay. Okay. Sounds good. So last time we learned it. If everything is given, I can figure out the design bending moment. Now, if the steel reinforcement is missed, so bending moment must be given. So I can figure out the value of area steel and I can check it. Someone will ask me a good question. He didn't ask me this. Okay, looks good. Looks good. You are talking about row minimum. We have here also row maximum. This value according to ACI, row when epsilon t equal 0.004, this one can be called row maximum. So your row from a table must fall between row minimum and smaller than row maximum. Row maximum happened at epsilon equal 0.004. This one, or this one, or this one. This row represents the maximum row. Why I don't need to exceed row maximum? Next week. Why I don't need to below row minimum? Also next week. We have three kind of cross section: over reinforcement, under reinforcement, or balanced section. We will cover the difference between all of them. We don't like by any way of steel reinforcement to exceed row maximum. It's a dangerous situation. We don't like this. How? I'm adding more reinforcement. More reinforcement means more safety. No, it's not more safety. We have a big issue will happen in your building if your steel reinforcement is too much. It's a very bad situation. I will cover this next week. Okay. One more example, but this example is more general a little bit. We will cover a little bit from structure analysis. Okay. Guys, we have reinforced RC means reinforced concrete, simply supported beam. Anybody remember what is the meaning of this expression from structure analysis? Do you remember? Simply supported? Simple. Very simple. That means we have a beam, very simple, just the support from this right and support from this left. That's it. Simply supported means very simple beam with an effective span. This length called span. How much? 12 feet. The cross section of this beam has overall depth. The total overall, the total depth 24 inch. And effective depth, if you have a steel reinforcement here, the effective depth will be 20 inch. And a width equal 12 inch. This width equal 12 inch. So I'm trying to read the problem and translate this information to graphical information. Steel reinforcement is grade 60 and normal weight concrete with compressive strength 4,000. Determine the area of reinforcement area steel. How much? Required for the beam to carry dead load 0.75 on weight not included, and the live load 1.1 kb per foot. Wow. We have dead load equal 0.75 kb per foot. on weight of the beam not included in this number. The problem said this. So I need to figure it out. Life load is given 1.1 hip per foot. This problem is very important, and we need to figure something. What you need to figure out? I need to figure out if you have a beam looks like this. Here is B, here is total depth, overall depth T. Can you tell me how can I figure out the weight of this beam for unit length? 1 feet. 1 feet means unit length. So I need to figure out the weight of this part of the cross section. Gamma equal, do you remember gamma? Equal weight per volume. So weight of anything in this real life equal gamma of material time volume of the beam, of the body. Keep in your mind, gamma concrete equal 150 pound per cubic feet. Please put this number in your mind. Normal weight concrete, this is for the normal concrete. Normal concrete. If we have something different, the problem will let you know. For normal concrete, gamma equal 150. How can I get a volume for this part of the cross section, of this part of the beam? Okay, volume for anything is the area of the base times this height. So B times T times unit length 1. This is the volume. If you multiply BT times 1 times gamma, which is 150, I can get weight per unit length. I can get the weight per unit length. For example, your beam, this beam in this problem has 12, 24 total depth, 12 inch, 24 inch. We are looking for unit length, 1 feet. So what is the own weight of this beam? Equal B 12 divide 12, T 24 divide 12, unit length 1. Here is the volume. This volume time gamma 150. So these terms, volume of unit length of the beam, unit length. 150 is the gamma. So if you multiply volume by gamma, I can figure out the weight. I have question. Why this 12 and why this 12? Because I need to convert this beam, this B, from inch to feet, and this T from inch to feet. So I divided both of them by 12 because the unit length in feet. So all of these numbers must be in feet. Time 150. So your final value will be 150 equal 300 pound. But this weight for unit length, so I can do it pound per foot, or equal 0.3 kb per foot. I divided it by 1000. If you have any question for this point, let me know. This point is very important. Very important. Very important. How can I figure out the weight, the on weight of the beam? Go ahead. This one is B divide 12. B is given in inch. So I need to divide it by 12 to convert it to feet. If this number is 14, so 14 divide 12. If this number is 16, 16 divide 12. If this number is 10, 10 divide 12. So 12 is constant. The denominator is constant to convert from inch to feet. So the numerator is B, whatever the value of B. Okay. So guys, this term can be done like this. B divide 12, T divide 12 times 1 times 150. Whatever this number, whatever this number. These numbers in inch. Okay. So right now, on weight equal 0.3 kb per foot. I need an answer. Alex, are you here? I think you are here. Yeah. Okay, Roberto, just a second. My question is, on weight of the beam, is it dead load or live load? Do you think you can go to campus and leave your weight at home? Can anybody do this? Hey, I'm coming to campus, but my own weight, my weight is at home. Can you do this? Do you remember from on-flance line? Dead load, we don't have a choice. I'm sorry, on weight is a dead load. So your dead load total, including the weight of the beam, will be 0.75, which is given, plus 0.3. We just calculate it. Your final will be 1.05 kb per foot. And your live load will remain the same, 1.1 kb per foot. Robert, your question is, what is 150? 150 is gamma of concrete. 150 is the gamma of concrete. We need to multiply volume times gamma. Volume is this value. 150 is gamma of concrete. We are talking about one type of concrete, which is normal weight. So this value will be constant, 150. Okay, Roberto? 150 is a common value for normal concrete. All the time it's 150. If you are talking about different type of concrete, the problem will let you know. Okay, guys? Okay. So by this moment, we have dead load equal 1.05 kb per foot. We have live load equal how much? 1.1. Anybody can tell me what is the value of U? Yeah. If you open first module in the first week, We are talking about ultimate. That's right. So we have a case of loading here. This one. Actually, we have only dead in this problem and life only. So I will use this one to get U, which can give you 1.2 dead plus 1.6 life. We don't have anything else. We don't have snow. We don't have earthquake. We don't have wind. We don't have roof life load. We don't have anything else. We just have dead and life. So I will multiply dead by 1.2, life by 1.6. We don't have LR, we don't have S, so this term is neglected. This equation will give you the maximum value, believe me. So 1.2 times dead, 105, plus 1.6 times 1.1. Your final answer will be 3.02 kb barefoot. Here is, I can call it W ultimate. Guys, one more time. This one called load combination. Because you are talking about ultimate, so I need to go back to the combinations for ultimate. I will found an equation called 1.2 dead load plus 1.6 life load plus something different. We don't have these terms, so I will only use the first part of our combination. 1.2 dead load plus 1.6 life load. Please put this equation in your mind also, because all the time in this course, we will cover only dead and life. This course only for dead and life. So all the time we will combine dead and life together. How can I do this in ultimate stage? I need to multiply dead load by 1.2 and the life load by 1.6. Until this moment, do you have any question? So guys, finally, your final load on the beam, which called ultimate load 3.02. So this beam has a uniform distributed load W ultimate equal 3.02 kb per foot. If you go back to structure analysis, if you have a beam with uniform distributed load W and length L, your bending moment looks like parabola, and this maximum moment equal W L square over 8. That means your W in this case 3.02. The length of this beam equal 20 feet. So your moment equal WL square over 8 will be 3.02 times L square divide 8. Your final moment will be 151 kb foot, and this moment is M ultimate. Wow. Wow. Why this moment is M ultimate? Because this W is W ultimate. Why this W is W ultimate? Because this W coming from this equation, you multiplied 1.2 times dead load plus 1.6 life load. So right now, M ultimate equal 151 kb foot. M ultimate is given. Cross-section dimension are given. Can you figure out the steel reinforcement? Yes, I can. So I need to figure out what is the value of M ultimate divide phi B D square. M ultimate, based on your calculation, 151 times 1000 to be in pound, times 12 to be in inch. Phi 0.9, B 12, D how much? 20 square. So I can figure out this value. $419. Open a table. And remember, you are in steel grade 60. F prime C is 4,000. Here is the table. Uh, 60,000 and 3,000 F prime C is 4,000. So I need to go to another table. Here you go. This one. 4,000, 60,000. What is the value of this one? 419. So go ahead and select 419. 419. I think you are talking about this one. We don't have 419, but we have 420. Rho equal 0.0075. Rho equal 0.0075. Go ahead and use this rho, or we need to make check. Oliver, if you figure out W L squared divide 8, W in kib per foot, L in foot. Your final moment will be kib foot. If you go back, dead load kib foot, life load kib foot. So if you are using this equation, your W will kib foot, your bending moment, everything in kib and everything in foot. So your final moment will be kib foot. Okay, so I need to convert this one to be pound inch. Anyway, so after you are done, rho equal 0.0075. I need to make a check. Go back to this table. You are talking about grade 60, but F prime C 4,000. So your rho minimum will be this number. I believe 0.0075 is greater than 0.0033. Also, be sure that you are under the maximum value. 0.0075 is smaller than 0.02. So you are between minimum and the maximum. You are good. Keep going. So rho equal 0.0075. Rho equal area steel divide B D. 0.0075 equal area steel divide B12 times 20. The only unknown here is area steel, so I can figure out the value of area steel equal 1.8 inch square. Can you convert this area steel? How many number of bar? Number 3. How many bars for number 4? How many bars of number 5? Then we can take a decision which one I will select. Actually, in your exam, only one option you can put it, this one or this one or this one. But I'm trying to show you if you are using number 3, how many bars. If you are using number 4, how many bars? If you are using number 5, let's see. Number 4, number 3, 1.4 divided 0.11. We need here 17 bars. Too much. Too much. Number 4, we will use 9 bars. Number 5, we will use 6 bars. I like this one. So 6 bars. Number 5 is the required area steel for our beam. We are looking for this final answer. So please don't stop to show me your area steel. Please go ahead and convert this area steel to how many bars. So it's your option, it's your opinion to select which size of bar, number 3 or number 4 or number 5. It's up to you. Once you select the desired bar size, go ahead and convert it to a number of bars. The key in this problem is how can I calculate the on weight of the beam? The on weight of the beam will be added to dead load. If you have dead load before from the problem and we have on weight, add them together. So we have dead load. Live load is given. We need to convert to make combination between dead load and the live load in ultimate stage. So I have to multiply dead by 1.2, live by 1.6. So finally, I got uniform distributed load ultimate. How much? This value. From structure analysis, if you have simply supported beam with uniform distributed, if you go back to structure analysis, especially for conjugate beam, your bending moment looks like parabola. This maximum moment equal W L square divide 8. W 3.02, which is coming from this equation. L, the total span of the beam. Square divide 8. This moment will be called M ultimate. Once you figure out the value of M ultimate, okay, we have very simple steps. This term, how much? Go to table to figure out the value of rho. Please be careful that your rho must be greater than rho minimum, smaller than rho maximum. Be careful. Okay, my rho is good. Your rho equal area steel divide BD. I can figure out the value of area steel. Then I can convert this area steel to how many bars based on your bar size. It looks like a very simple problem, but we have different things we need to cover. This problem looks like a problem in your PE exam. In your PE exam, probably you can given this information. So you need to figure out the on weight. You need to figure out the ultimate load. So you need to multiply 1.2 dead load plus 1.6 live load. You need to get the M ultimate. You need to go to the table to figure out rho. You need to check. You need to get area steel. You need to convert how many bars from the bar size. And you need to solve this problem in 6 minutes. Only. No, D. Okay, it's a good question, Alex. You are talking about, if you are talking about on weight, we need to include all concrete in the cross section. So we are talking about the total thickness. Okay, so the total thickness, everything in the cross section, the total height, if you are talking about on weight. But if you are talking about design, M ultimate divide phi B D square, this D, please until steel reinforcement only. Until steel reinforcement. Okay? So we have two situations here. It's a good question, Alex. Thank you. If you are talking about on weight means I need to include everything in the cross section, everything. So the total height, the total thickness, 24. But in design, no, we need to consider only until steel reinforcement. So this D will be until steel reinforcement only. Okay? Any other question? We have homework, 3 problems like these 3 examples. Example number 1, example number 2, example number 3. The same. But please pay attention and understand the story. We are walking through a long story. Long story. Okay? So next week, I will continue to understand something. Why we need area steel to be between rho maximum and rho minimum. What will happen if rho is greater than rho maximum? What will happen if rho smaller than rho minimum? What will happen? We will see next week. Also, next week, how can I figure out the dimension of the cross section? In these problems, dimensions are given. Can I figure out these dimensions? Yes, you can.